Hey guys, Mrs. Taylor here. Today we're going to be talking about one-step equations. This is going to be corresponding with page R58 in your notebooks. So if you could take out your spirals, we're going to get started on page R58. One-step equations, obviously, are equations. Remember, that's a number sentence that has an equal sign. One step, it's going to happen in one step. We're going to look for balance on equations. We have 4 examples, actually we have 5 examples for today. Our first one is using addition, then we'll go through multiplication, division, subtraction, all of those. So, we have an x, and we have some numbers. What we're going to try to do, our goal is to figure out, well, what is the value of x? We're doing something to x, we have an answer, and we can work backwards to figure out what the value of x truly is. So, we've done this before. We're going to draw a T to represent our balance. I see that I am starting with x plus 8. If I see addition, I can go backwards. I can undo my addition by using subtraction. I know that a positive 8 is the opposite, or the inverse, of negative 8. So using my inverse property of addition, if I add a positive 8 and a negative 8, they'll cancel each other out. However, let's remember, whatever I do to one side, I have to do to the other side. So now when I do my math, I go through, these will cancel each other out. I'm left with x equals. Using your integer rules, 3 subtract 8. You can do it. 3 subtract 8. You can use your calculator, or maybe you'll need to LCO that. 3 plus negative 8, we end up with an answer of negative 5. So that was our example with addition. Now we have an example that uses subtraction. X minus 5 equals 2. I'm going to draw my T for balance. Hopefully you can see that. I see subtraction. I want to get the opposite, or the inverse, of the negative 5. So the inverse of negative 5 is a positive 5. So I can add 5. Remember, whatever I do to one side, I do to the other side. Add 5. So I can use my awesome integer skills. I have minus 5 and plus 5. They will cancel each other out. X equals 2 plus 5, 7. Keep following along on your paper. You should be writing anything that's happening up here. Here's an example with multiplication. Remember, when 2 things are stuck together like this, I have a number, a term, and a variable. This is the coefficient and the variable. What's happening in here between these 2 is multiplication. So let's remember, that's negative 4 times x. I see multiplication. I do division. The opposite operation to multiplication is division. So I have negative 4 times x equals 20. I would like to divide. Because I see this multiplication, I'm going to divide both sides by 4. Negative 4. Negative 4 divided by negative 4. Anything times itself. Inverse property. These will cancel each other out. I have a plain old x. 20 divided by negative 4. Positive divided by negative equals negative 5. Next example. X divided by 7 equals negative 4. I have to draw a T, but this time I'm not going to make it quite as large. I'm going to do my work above the T. I see this 7. X divided by 7. This time I'm going to, instead of divide, to balance out, to get rid of, and work backwards from division, I'm going to use multiplication. If I multiply 7 times x over 7, these can cancel each other out, and I will get an x by itself. However, anything I do to one side, I have to do to the other side. If I put that 4 over 1, looks a little similar. I work straight across. 4 times 7, 28. What?
It's -4.
It sure is a -4. Okay, negative times a positive is a negative. So -28. Thank you, Mr. Eden. All right, one last example. It looks a little bit tricky because it has a fraction, but it's not, because we know what to do. We know that anything times its reciprocal will equal 1. We learned that in our properties. Multiplicative inverse property. So I'm seeing 2/3 times x equals 12. I want to get the x by itself. So I'm trying to make this 2/3 go away. If I multiply by the reciprocal, 3 over 2, this will cancel out, and I'm end up with x by itself. Anything I do to one side, I have to do to the other side. Again, I'm going to put that like this. So what I'm having here is 12 times over 1 times 3 over 2. A couple ways I can do this. I can go straight across and simplify later, or I can simplify first by getting some smaller numbers that are easier to work with. I know that I can cross simplify like this. Now I have 6 times 3 over 1 times 1, or simply x equals 18. Those are 5 examples of how we're going to be doing one-step equations. Make sure you understand how this goes. If you need to listen again, listen again. When you come in next class, be ready. We're going to be doing lots of practice in class. Have a good evening.